start with the second subtopic of this chapter, which is dispersion, which indicates the amount of extent up to which a value in a dataset can spread or deviate from either any of its central tendency metrics. For example, let's say certain values have been provided to you: x2, x3, x4, x5. I'm taking the example of an ungrouped data. Here you calculate the mean to be x bar, and now the data set was of just 5 numbers. Now let's say if x6 arrives, a number arrives, and we know the value of x bar, so the difference between these two numbers, the deviation of x6 from the average of first 5 numbers, this is what we call dispersion. I hope you are understanding. So dispersion is nothing but the mod of next data point minus x bar mod. So there are a certain number of data points that have been provided to you. From that you calculate any of the central tendency, which is mean, median or mode, and then you've got an average value or a specific value to represent that entire data set. Now whenever a new value comes in this data set, you will know what is the difference or what is the deviation of that data point from the average or mean of this data set that you had taken out. So generally it is calculated using mean and median. Mode is not considered a lot, but still it is used to calculate dispersion. So let's look at its subtopics. One is range. Range is nothing but the value up to which the data point can deviate from any of its central tendency. So you can see the formula for range is maximum value minus minimum value. Sorry for that. Maximum minus minimum value. Now another subtopic is mean deviation. Now, this is an important part. This will help you understand variance and standard deviation as well in the future. So mean deviation is calculated about mean and median. Again, it cannot be calculated about the mode of any given data set. Now it is the absolute difference, the average of absolute difference that has been provided to you. For example, let's say x1, x2, x3, x4, x5 has been given to you. Now you take out the mean. Let us calculate this about the mean. And now you got the mean to be x bar. Now there are 3 more data points that has been provided to you. Now from here, these 3 data points and the mean, you can calculate what is the dispersion here, or you can refer it to as deviation from the mean. Now once you've taken out the differences, the deviation, now you have to take the average of those deviations. That would be your mean deviation. So basically our mean deviation here, it would become mod of x6 minus x bar plus mod of x7 minus x bar plus mod of x8 minus x bar divided by 3, since there are 3 new terms that have been added, 3 times differencing. This is our mean deviation of certain number of points that are given. This is about the central value, which is mean. Now it could have been median as well, so it works for both. Again, just remember this thing, mean deviation does not work for mode. Now here are basically simple formulas as to how you can calculate mean deviation. For ungrouped data, we had just seen with an example how mean deviation can be calculated. For group data, sorry, this is about median. These two are for ungrouped data. One is for mean and median. Again, the formula remains the same. Just the thing is, mean is replaced by median, and same thing would happen for group data as well. Mean is replaced by median, and there is an fi factor which is getting included in both the formulas, in the numerator as well as denominator. Very simple. Again, a formula based thing. Now variance. Variance is nothing but the square of those differences. Now again, for ungrouped data, sigma square is how you represent variance, you need to remember this very importantly. Sigma square, not sigma. Sigma would identify something else. We will look at that in the further slides. Again, it is the differences of deviation of squares. You can see xi minus x bar has been squared and then the mean has been taken out. So that is how variance is calculated. Now the square root of this variance is standard deviation. So we can write standard deviation is square root of variance. So this was the formula that we had studied in the previous slide, and that is the exact formula, just a square root has been added for standard deviation. Now there is an alternative way to calculate standard deviation as well, if let's say variance had not been provided to us. So what we can do is we can try to break down this square term and try to create an alternate formula for standard deviation. Let's look at that here. If you break it up, then after a lot of equations and equating a few other things, you would get this to be a standard deviation. Xi square minus xi by n whole squared. For group data, it would become fi xi again. It remains the same thing for ungrouped or grouped. Just the thing is, for group data, sigma fi gets added each and everywhere. So you need to remember these formulas. Again, important things. Just remembering these formulas can help you get 4 marks in JEE mains, because there is one question asked based on these formulas. Now that was all for dispersion. Now some extra information, and then we'll look at a trick through which you can easily solve your central tendency and dispersion questions. So this is a combined mean formula. This is also known as a weighted average. So what is this? Basically, let's say if you were given two different data sets, one which has n1 number of points and the other which has n2 number of points, and you calculate the mean of both the data sets. The mean of the first data set is x1 bar and the other one is x2 bar. Now you have been asked to find out the combined mean of these two data sets. So this is the formula that you use to calculate it: n1 x1 bar plus n2 x2 bar upon n1 plus x2. Now this is another formula that you need to remember: coefficient of variance. Coefficient of variance is represented as sigma by x bar into 100. Now remember, this sigma here is not variance, this is standard deviation. So don't confuse yourself with the name as it suggests coefficient of variance and you input the value of variance in this formula. This is standard deviation, sigma by x bar into 100, and you will get it in the form of a percentage. Now again, if two data sets has been provided to you and you've calculated the standard deviation of one, now you have to calculate the standard deviation of combined data sets. So this is the formula for that. Again, an important formula that you need to remember. Where sigma combined is n1 sigma 1 square plus n2 sigma 2 square plus n1 n2 upon n1 plus n2, x1 bar minus x2 bar whole square upon n1 plus n2. Here x1 is a mean and sigma is standard deviation. This is sigma, standard deviation. Now let's look at a shortcut trick, or a trick how you can solve general central tendency and dispersion questions. Let's say a data set has been provided to you: x3, x4, x5, let's say 5. And if you were to add or subtract a constant value to each and every term. First, let me define one thing. You found out mean to be x bar. You found out medium to be capital N, median. You found out mode to be represented by some formula from some variable. You found out sigma for this 5 values. You found out variance for these 5 values. Now what would happen if I were to change or somehow add or subtract or multiply a certain constant to each and every value of this data set? How would our mean, median, mode, sigma and sigma square would change? That is a trick that you need to remember. So let's say if I were to add or subtract to each and every term, let's say k is the constant term that I'm adding or subtracting. So my new mean would simply become, you simply just add or subtract the value of k from the old mean, you will get the new mean. And what my new median would become, again the same thing, median plus minus k. And for new mode plus minus k. This is how the value of central tendency would change if I were to add or subtract any constant term k to each and every term of the data set. However, now this does not work for variance. For variance, which is sigma square, this would remain same, sigma square only. And for standard deviation, which is sigma, this would also remain same. There would be no changes in this thing. So an important thing that you need to remember, if you are able to remember this thing, you will be able to solve questions within seconds of this chapter. Now let's look at a different perspective of adding k or to this data set. Now let's say if I were to multiply k to each and every term of this data set, then what would happen to my mean, median, mode, sigma and variance? My new mean would simply become k into old mean. My new median would become k into old median. My new mode would become k into new mode. Again, no changes if k is multiplied to each and every term of the data set, then our new mean, median and mode would also be multiplied with k. However, now again you will see changes in variation and standard deviation. If I were to find out the variance, which is sigma square, this would become k square sigma square. So you see, this is the old one and k is the constant that we are multiplying, so it is squared and then getting multiplied. And for standard deviation, which is sigma, it is going to be mod k into old sigma. So again, an important thing that can help you find out the values more easily. Now let's say another thing, which is x1, if I divide each and every term by k, then what would happen to my new mean? This would also be divided by k. Again, the same for median and the same for mode. So now I hope you must have gotten an idea that all the metrics of central tendency tend to remain same according to each other, even if, let's say, if mean changes, so in that similar way, median and mode would also change of that data set. However, this does not work for variance and standard deviation, since they are dispersion metrics. They change in a very different way. Now here again, variance would change in a very different way, which is sigma square, which would become old sigma square, which is old variance, by k square. And standard deviation would become sigma by mod k. So again, another thing that you need to remember. So again, these are the three shortcut tables that you need to remember. This would help you solve questions very easily in JEE mains. And when at the end of this chapter, we've almost come to the end of this chapter. In the end, when we will start solving previous year JEE main question, you will see a few questions which are based on these evaluations, and you will see how easily they can be calculated if you are able to remember all these three tables.